Hello and welcome to another session from GDG Oslo. My name is Majid and I'll be your host, one of the organizers of GDG Oslo. And today I have a great pleasure to introduce a great speaker with us, talking about perhaps one of my favorite topics, security. We're going to have Merab together. But before that, please. Just as always, when we start an online session, well, we have a code of conduct, and that's fairly simple. Is we need to be nice to each other. That's the only thing we should follow into like during the session. And with that said, I will not keep you waited. We have Merab today talking about security. Let's welcome Merab. And hello, Merab.
Hi. Thank you for hosting me, and hello everyone. So I hope this will be interesting topic for you as well because I really love that
I'm
field.
pretty sure it will be Merab. But before we start, Merab, can you introduce yourself? I didn't want to do that, so go ahead and introduce yourself, please.
Okay. I'm Merab Kutalia. I'm Android GD, actively contributing to the open source and plus active participating into cybersecurity, doing catch the flags, doing bounty, bug bounties and so on. So that's me.
All right, very nice, Merab. So, do you want to talk about your topic a bit before you start? Just maybe a few words.
Yeah, so this topic will be interesting mostly for the developers who already have the experience with the mostly mobile development, Android or iOS, and they want to expand their knowledge regarding to the security, mostly how we can scan our applications, what are potential pitfalls when building the common functionality, and also how we can protect ourselves from the attacks, mostly like chain supply attacks. Most concrete example is that when you have some weird dependencies crippling into your code base without knowing, and accidentally you find them later in the production or something like this. So this is really tricky topic, and can be expanded, and like it is all reviewed by some mm, top security guys, folks around the world, but still on the development level this is sometimes very overlooked topic, and I want to reintroduce this to everyone and have much more awareness.
All right. So, well, I think I should not keep anyone waited. So I'll remove myself from the screen and I leave the stage to you, Merab. Good luck.
Yeah, thank you. Thank you. So I'll not bother introducing myself. The topic is, let's go straight to the topic. The topic is make code bases secure with OWASP. We'll talk about the OWASP. What is the OWASP if you don't know yet? First, let's talk what is secure software and what the term secure means. Okay, we have heard that there are many hackers out there who hack on a different level, like a website, network protocols. They can hack operating systems. They can hack the binaries and the stuff like this. But this hack is ambiguous word. So actually, when we building software, we always have security in mind, or we should have it, like managing the access controls, data protection, and those points are sometimes overlooked, and it really depends on the company's um, domain, where the company is operating, and also the size of the company. For example, the banks or other financial institutions, and the large organizations, they protect data differently because it is like user data, user transactions. They can determine user behavior and so on. So data protection is very much needed, but on a different level, unlike some small application or for the like some kind of mini or like indie game developer, yeah, to compare. But the baseline of this topic is that we always need to think about the users and what data is transferred from a user to our servers, and of course to protect against the vulnerabilities. So I will not be talking about the data protection itself and managing access controls, because data protection is more like infosec world, and probably there will be people who can explain this concept and the tools better than me. But on today's topic, I'll focus solely on the tools that we can help in and use it in our development process, use it on our continuous integration servers, and to actually have it in our tool chain. Yeah. So let's talk about the protection against the vulnerabilities. So vulnerabilities are also comes in a different forms. Um, During the introduction, I mentioned chain supply attack, and this is very, very common in today's world. And this kind of attack is uh, focusing not the users, like in the long run. Of course, it focuses the users and some kind of data, or they need to mine some kind of data. But the attack vector is quite different. They attack the developers, they attack the company's development cycle. So it's like when you imagine you have some kind of dependency, let's call it like uh, left padding like module, for example. Uh, Imagine it's on npm, some kind of JavaScript library, left padding, and other developer, the malicious actor, crafted the same like same dependency, but added some kind of malicious code that can ping to other server and send the like the directory names of the file system, or anything else. I don't know. There are plenty of like directions to like improvise, but and put this almost same dependency on the npm with a slightly changed like name, like left padding with a double d or double e or something like this that can be easily misspelled. So and developers sometimes can misspell those words and introduce different dependencies other than the actual real one. So this is a problem there. And if your like cyber hygiene is not uh, on top, and your company's internal cycle of development is not well built, this dependency can slip into the production quite easily. So today I try to provide the correct tooling and give you information that you can block those kind of problems be, before like putting it on production. You can find those kind of dependencies on your like first run. So include the dependency, you built it, boom, and you know that something is not correct, and you have the proper tooling for this. So before we dive into the tooling itself, let's advance a step further and talk what is a secure coding startup. So we know that we need like secure software. We have to protect against vulnerabilities, and with the vulnerabilities and all the good stuff, we still need to introduce the security measures in our code base itself. For example, most like commonly used best practice is that you should not save your passwords in a string data type, like it's like 2 by 2. But still, we see lots of code bases with the same mistake, and on and on. So the problem with the string is that every time you need to do some kind of operation and you pass it, it's like immutable. It is copied into the memory, and it stays in the memory. Instead, you can use like byte array or char array, which you can immediately clean and null away. So you leave the very little window for an attacker to really dump your password. So if an attacker has some kind of access to your uh, phone or system and dumps the memory, like dumps some kind of snapshot of the memory, if you use strings and other types, it's like you leave a larger window to actually penetrate into that. But using the proper data types, these windows are drastically shortened. There's still window, there's still time that it can be snapshotted there and understand what's in the memory, but still you try to resist, and you try to build a more secure system. Of course, this is only a single example, and those examples can go on and on. And that's why the secure coding standards are with us. And basically, secure coding standards are what we know, most of us at least know by heart. Sometimes we don't realize that we use it, but still. So secure coding standards are the rules and guidelines just to prevent security vulnerabilities. That's simple as that. And to like use it, this secure coding standard is like first the prevention, uh, like detection, prevention, and then to eliminate. But it is always good to prevent rather than they eliminate later. So the prevention is a really important step here, that we always need to be in a prevention mode. We always need to like put more and more security for us and for other developers. Imagine being a team lead, and you have like 3 or 4 juniors in your team, you have seniors, you have middle level developers, and you need to create some kind of safe boundaries, that like safe framework, like working frameworks that everyone is still comfortable with, but you have like safeguards to actually protect your code base. Why we need to care? As we mentioned, leaking user data, and this is like number one topic. With the losing user data and so on, the second stage is that you lose your reputation as an organization, as an individual. Even if you don't lose any kind of data, if some kind of breach happened, you still lose your reputation, and reputation matters. Most of the time, businesses are built on the reputation and unsafe development processes, and you always need to analyze what are the development processes you have. Like we've seen several months ago very nasty like 0-day, probably you have heard, it's log4j, Java logging library, which allowed in specific scenario with the specific versions remote code execution. It it this kind of bug was sitting in a code base for a while, but nobody noticed, despite being it on in a open source, discovered and publicly disclosed. The whole world went crazy, and appeared that no one was updating libraries and actually filtering the vulnerabilities, and it was a disaster. And same applies not only log4j, but lots of other libraries that we don't know if there is some kind of problem. Okay, what to do? Um, we mentioned that secure coding standards are just the best practices to prevent and avoid the unsafe behaviors in our code base. So actually, the number one step is to follow the standards and best practices um, from the library developers, from the programming language developers, from the platform developers. Um, for example, for the JVM, we should follow the best practices given from the Oracle, from the rest of the Java developers. For the Android, it is always best to just go through the documentation of the official Android documentation and see how is it what's the correct way to handle data, maybe what is the correct way to load the web view inside the application, what's the correct way to store user sensitive data on the device, and how we can like store it even. So I want to give you one example which is like very concrete example, but also like how to say, you can so everything can go wrong in a single move, or um, it's like everything go to the disaster. Imagine mobile bank, like full-fledged mobile bank with user biometrics authentication. Like you put the fingerprint there, and boom, you are in. So um, the Android biometrics offer the nice API for you, and it's really easy to integrate there. And imagine scenario when you have the device in your hands and you can add a new fingerprint on the device. So most of the devices hold up to 5 fingers. You have five fingers, max entries. So what if user adds new finger in the system, and when you open the mobile bank, the application like logs you in without a problem, because it trusts the system, said, okay, this is a verified fingerprint, I can move on. But what if someone like malicious actor, the attacker, I don't know what you want to call, um, have access to the phone? Maybe you left your phone like 15 seconds unlocked on a table, and someone just grabbed it and added the fingerprint there. What happens there? It means that this attacker has the access to the your bank account, to your it's like to your sorry, background, sorry again. So it means that it can access to your bank account and to your phone. The Android also suggests in their documentation disable biometrics, like make it invalid biometrics whenever user adds, like changes the fingerprint entries. So if the user adds new fingerprint or removes one, or something alters the fingerprint key store, so your application will no longer actually log the user in, because you know that this is not the valid biometrics anymore. This is one of the best practices from Android, but totally overlooked many developers and applications, like even including the mobile bank. So when I see this, it's like very scary. And those kinds of best practices, the result is that those kind of best practices are commonly overlooked. So please always consider like going through all the kind of documentation regarding to security. Don't skip the security part in the documentation, and just don't just try to implement the like main functionality and skip the security part and the hard part mostly. So same applies to Apple and iOS systems, so you can always go through the documentation. Okay, enough with the documentation and so on. Uh, the another part of this and more agile for us are several ones like OWASP, CV, and CERT. Let's talk about those guys. OWASP is like we will talk about the OWASP a bit later, but OWASP top 10 is the list of common Android, like Android slash iOS vulnerabilities and the problems that can really appear in our application. And the OWASP gives us the concrete checklist, what can be tested, what can be like done to avoid those kind of problems and so on. So this is the OWASP, and we will talk about the OWASP a bit later. So let's talk about the CVE. CVE is a publicly disclosed cybersecurity vulnerabilities list that is free to search, use, and like incorporate into products and services. This line I copied from the official CVE website, so that's why it looks so fancy to like actually pronounce. But basically it's just the open source database where you can see all the public vulnerabilities from the recent years, actually understand what's going on, and CV numbers are assigned to the uh, disclosed vulnerabilities. For example, I remember from the last year there was also remote code execution vulnerability in the Instagram. If I recall correctly, it was into the image processing library. It was written by Mozilla, if I recall correctly, and it was written on the native level like C, C++, and it was some kind of bug which allowed buffer overflow and allowed remote code execution. So you can check those CVs and understand how dangerous is to put the dependencies and actually take the tech debt for this. Yeah, the CERT is like computer emergency readiness team. Most of the countries, the governments have their official CERT like teams to help you with the computer emergency, to understand they stand in a front line, they understand what are the newest 0 days, what are the vulnerabilities, and help you and your companies to like patch them quick, and also give you information that something is happening, and yeah, be safe. So moving on, what is the OWASP? The OWASP is the Open Web Application Security Project. This is acronym, and actually, I'm one of the lead from my local OWASP Tbilisi chapter, and I sometimes speak on OWASP chapters as a speaker. So OWASP is a really, really nice community, providing tools and resources for free, community and networking, of course, and the education trainings there. So it's a really, really nice community of cybersecurity enthusiasts and professionals. So if you are traveling to another city, or you have and always please check out the OWASP chapters, and if there's some kind of conference or something like this, because you will like you will end up knowing a lot more, and also like you will be a little bit frightened at what's going on in the world. So the OWASP top 10 is a list which I already mentioned, and I will not go through all of them, just quickly um, like take a glance on them. It's like, as I mentioned, the improper platform usage. This is how you can use the correctly Android platform, and what are the potential pitfalls. Insecure data storage, as I mentioned, how you can store user data, insecure communication, that okay, it's 2022, everything is under the and we use HTTPS, they use serve, and
All right. It seems we lost Merab, unfortunately. So let me see if I can. It seems like he's back. Let's. Merab, are you here?
yeah, I'm here. I don't know what happened. Maybe some kind of internet drop because I'm outside. Sorry for that. Um, yeah, I was talking about the insufficient cryptography. Like cryptography
Yeah, you need
is
to
hard.
reshare your screen. We lost everything. So yeah, please reshare your screen. I
Uh,
will.
yep. Sorry for that.
No problem. Then I'll leave the stage to you.
Yeah. Thank you. So insufficient learning curve. So OWASP the tips helps us with the actual examples and helps us to do all the stuff with within ease. Also insecure authorization, client code quality, code tempering. This is like very actual topic, and reverse engineering, how we can protect against the reverse engineering, because there are lots of tools, and I've done talk on the DroidCon 2 years ago, how we can do like static reverse engineering, and also how we can do dynamic analysis with a FRIDA tool. So it's like you have physical device, and you can do everything with an application dynamically, so to hook into the memory itself. So FRIDA is very powerful tool, and somehow to protect our application against it. Remember that nothing is unbreakable. Everything can be broken, and every secure measure can be defeated. But this is a matter how far someone needs to go. So we can resist as much as we can, and it then comes the topic that is it worth it or not. So if you have good security measures, is it worth it to like somehow break those security things, or leave it alone, or don't give everything to the attacker, and try to resist as much as possible. So this is a like top 10, and you should really go through the top 10. Spend one evening with the OWASP open the sample project, and try to understand these things about the guide. Again, from the OWASP, and this talk is mostly helping security with the OWASP Mobile Security Testing Guide. This is not bound only for Android, so it's Android plus iOS security standards for the applications. And it is always updating. You can also contribute to that if you feel if you feel like you have something to tell the OWASP community, feel free to just give the feedback and the any news you have. So this testing guide is a small PDF or like Markdown, as you wish, to like how you can test your application. So you know that okay, cryptography. So OWASP Top 10 talks about okay, it is better to use those kind of cryptography. Use like key store provided from the by the Android, and so on. But how you can test this? This security checklist gives you everything. So it's like Excel spreadsheet, comes with the PDF, and there's steps. Okay, user application compliant to that and that, and you can check directly into the source code and understand if it does comply to the rules, and you check the mark in the Excel. Of course, not all the not all the items from checklist apply to the application, because again application still. And the last tool I want to talk about mm, is to check the dependencies with the OWASP. So this is the most important tool I want to talk about you today, because this is a tool that you can use as a one of the strongest tool in your security tool chain. Like OWASP dependency check is a like um, binary supported on all platforms. Maybe I should turn off the camera because I see it's a little bit lagging. So it is supported on all platforms. It's on Android, iOS, Mac, Windows, Linux, everything. And it checks third-party libraries into your which are used in your project. It has the public database, something like CV database, um, uh, and it assigns some kind of score, like severe to the totally safe and free to use, some kind of score, and generates the result. And it includes the transitive dependencies. So if you have uh, like networking library, and this networking library has some kind of dependencies, it means that you get the report including those transitive dependencies as well, and you analyze it. And if there's some kind of problem with the dependencies, then you use the magic from the maybe Gradle, and you can swap dependencies, exclude dependencies, resolve the conflicts, and so on. So it is a really nice tool. And depending on the project, and if you have a, so it means that uh, you try to be as strict as possible. You don't want anything to be in alerts, and you want a clean report. Of course, using this tool means that on your first run, you probably will get lots of alerts. You can create the baseline, like exclude list, and you can like suppress all warnings, and start from the clean paper and try to slowly migrate from the libraries and close false positives. You can always check the false positives, like check with the library developer, and also in the public database there's some kind of comments as well, that if this is really a problem in that specific domain. So yeah, false positives uh, are the biggest problem doing this dependency check, and you really need to go down the rabbit hole to really understand what's going on there. I want to like show you implementation on Android, how it can be done, and it's very easy, and you quickly grasp the idea how we can integrate into the continuous integration as well. So the first step is that we can like include it in a class path. So it is also on Gradle plugins portal. So for the if you use Gradle plugins API, you don't need plugin, and it comes with the advanced setup, which will help you on the CI. So fail build on CVSS. This is a the score, and I'll show the scoreboard later, that you want to fail build. It's like from 0 to 10. And 10 means that if your vulnerabilities accumulated score is 8, 7, 10, or anything, it means that what is the tolerance? So what points, what is the score that you are okay with this? So if you think that the score 3 is okay for you, then yeah, it will not fail the build. Otherwise, it will fail. So 0 means that it will always fail if there is a non-zero score there. So yeah, let's see the scoreboard a little bit later, and you can also include the scan configurations and see what's going on there. For example, you don't want to test Android test directory, test debug versions also, and you want to check the implementation and runtime only. So you can always do your setup and choose the build variant you want. And this is a report, actually, as a sample, how it looks like. Like there's some kind of false positives there, of course, some kind of vulnerabilities which actually is not problematic for your application compile, or it's not really configuration, and it's not a problem for you. So it really depends on your strategy, your internal company processes, and so on, how you handle. So this tool only gives you the information like nicely, and then it's up to you if you ignore it or how you digest this information. And if you look closely on the right hand side, you have CV count, like how many, as we mentioned, CV is publicly disclosed vulnerabilities, and how many vulnerabilities are found regarding to that package. Also, what is the evidence count, what is the confidence also. So then you can calculate, like, take the probabilities that this is not the false positive. And dependency check has a really nice documentation how we can suppress the false positive, how to analyze it, because it generates, I don't know, the very, very long HTML or XML file, and you have tons of information regarding to the all the individual dependencies there. And let's talk about the scores we used in a like in a Gradle configuration. It means that uh, 0 is at none, so everything is good, and yeah, you are good to go. From 0 to 4 is a low, like um, low quality. It means that 0 to 4 is actually good, because the quality level of the vulnerabilities are low, and then it goes up and up, and this is like standard table. And if you report of pen testing to your, you get long list of problems in your application, and every entry has its own score. Like if it's fatal, is it like okay, normal, is it good? And it uses almost the same scoring system, like commonly Walmart scoring system, which is standard. So from 4 to 7 it's a medium, and this is just a system. So still everything is up to you, up to your internal company system. But of course, the security is the thing that we always try to be less tolerable, to resist as much as possible, to put the secure measures first. And yeah, that's the point of those tools. Bonus point, which I have not mentioned here, is how we can protect our dependencies beyond the dependency check. So we can always check the dependencies with the like with the checksums. There's a even Gradle itself and build tools. So when you on a CI server, when you download the Gradle, first you can like check until you execute that. If your downloaded Gradle binary checksum actually equals to the checksum provided by the official Gradle website. This is like must. And beyond this step, you can always check all the of your like to the provided from the developer, and this guarantees that it's not tampered, and guarantees that it's not tempered on the fly, but it doesn't guarantee that you have the current dependency. So to filter the current dependencies and the vulnerabilities inside the dependencies, you have to use this Gradle dependency check. And of course, there are plenty of other options like Fortify, some other like other solutions, which like corporate solutions, vendor solutions, which are probably very expensive. There are also like for the static code analysis, SonarQube, and lots of tools that sometimes they are hard to use, not very developer centric, but still, if you really care about the security and the professionalism of the developer, because for developers it's not only coding, so we should care about the security as well. Go check out these awesome tools and be ready for a future and try to prevent this, and then implement it into your company and help others also to get onboarding, get onboarded and be and build more secure applications. Um, Basically, that was it. Thank you for listening. Thank you for your attention. And yeah, that's it.
All right. Thank you very much, Merab. I think this was actually very great. I'm a big fan of these security things that you mentioned, and it was refreshing to listen to you right now. It was great to talk, and you had great points also here. I believe everyone enjoyed this session. I'm pretty sure. Let's see if we have some questions for you. All right. So I don't. If you see if you have any question, please go ahead and write in the chat. I'll ask Merab. Um, Meanwhile, maybe Merab. So this was great for sure. How can people get access to these slides?
So I will publish these slides on Speaker Deck, and it will be available in 5 minutes. So I'll send you a link, and
Perfect.
also. Yeah. And also, if anyone has some kind of question, you can connect me on Twitter or LinkedIn and shoot your questions there.
Perfect. Perfect. So we don't have any question right now, Merab. So feel free to publish your slides and let us know, and we will put that hopefully in the comments in the under the video when we have this published on YouTube. It's already gonna be available right after we finish this session. You will see, everything. Don't worry about it. So, Merab, if you don't have anything else to share with us, then we should say thank you to you, and probably thanks other ones who are watching us right now. Do you have anything to share, Merab? Last things? No.
No. I just want to thank you, and yeah. Bye. Have a good day.
Thank you very much, Merab, and thank you very much for joining us and watching this video together. So, see you next time. Have a nice day.
Bye. Thanks.